In the second tutorial of section 8.5, we are going to solve a problem including a set of functions passing through a given point and having a relation f prime n of x equal to fn minus 1 of x. Then we having a set of functions with a relation and passing through a given point. We are asked to find or to solve such a problem. For better understanding for this idea, we are going to set of exercises 8e, page 141, exercise number 4, where a set of curves that each pass through the origin, then all the curves that we have are passing through the point 0, 0, have the equation y equal f1 of x, y equal f2 of x, y equal f3 of x, and so on, where f prime of n of x equal fn minus 1 of x and f1 of x equal x squared. Then we have a given that the first f of x or f1 of x is equal to x squared. Therefore, now we are asked in part A to find f2 of x and f3 of x. Then in part B, we are asked to suggest an expression for fn of x. First of all, let's try to think logically about f2 of x and f1 of x. We already have the relation that is f prime n of x equal to fn minus 1 of x. Then we can say now f2 prime of x, if we substitute in the form or in the formula given, then f prime 2 of x is going to be equal to f n minus 1 is 2 minus 1 is 1 of x, and f of f1 of x is given. Therefore, we say f prime 2 of x equal to f1 of x, that is x squared. Therefore, now we can find the value of f2 of x because we have its derivative. Therefore, we say f2 of x equal the integration of f prime 2 of x with respect to x. Let's substitute now the value of f prime 2 of x. So we get x squared dx, and we are asked to find its integration. The integration of x squared is x n to the plus 1 or 3 divided by n plus 1, that is 3 plus the constant c. Then f2 of x or y equal to x3 over 3 plus c. To find the constant c, now we substitute the given point that is the origin x0, y0. Therefore, we get 0 equal to 0 cubed over 3 plus c, then c, the constant, is 0. Therefore, we can say now f2 of x equal to x cubed over 3. Using the recurrence relationship, we were able to find the value of f2 of x. Now, if we want to find the value of f3 of x, so we go to the same relationship and we write f prime 3 of x equal to fn minus 1 or 3 minus 1, that is f2 of x. f2 of x, we just found it, so we substituted directly f prime 3 of x equal to f2 of x, that is x cubed over 3. Now, in order to find f3 of x, we have to find the integration of f prime 3 of x with respect to x. Then we have to find the integration of x cubed over 3 with respect to x. This is equal to 1 over 3. We take it outside, and the integration of x cubed is x to the power 4 over 4 plus the constant c. Then we say it's equal to x power 4 over 12 plus the constant c. This is the value of y or f3 of x. To find c, we substitute now x0, y0, the origin point. Then we get 0 equal 0 power 4 over 12 plus c, then c is equal to 0. Therefore, f3 of x is equal to x to the power 4 over 12. This way, we were able to find f2 of x and f3 of x that are requested in part A using the recurrence relationship that we have.